Johnny uses a wheelbarrow to move planting soil to a delivery truck. The volume of planting soil that fits in the wheelbarrow measures 2 feet by 3 feet by 1.5 feet. The delivery truck measures 11 feet by 8 feet and is 6 feet tall. Johnny puts planting soil in the delivery truck until the truck is 70% full. What is the minimum number of times Johnny needs to use the wheelbarrow until the delivery truck is 70% full? Okay, so we have some large delivery truck, and this will be, we'll say this is the container for that delivery truck. Here's the truck, and this space is 11 feet by 8 feet by 6 feet, which gives us a volume, we'll say VT for volume of the truck, of 11 times 8 times 6. The volume of a rectangular prism is the length times the width times the height, okay? So it's going to be 11 feet times 8 feet times 6 feet, which is 528 cubic feet. That means if you had a foot, rather if you had a cube that was 1 foot by 1 foot by 1 foot, this entire volume would be 528 of those cubes all stacked up. All right, let's find the volume of the wheelbarrow. Volume of the wheelbarrow. We can also presume it's a rectangular prism. They didn't tell us that, but the fact they gave us these three measurements, we can assume that it must be a rectangular prism. And so it's going to be base times width times the height. And so we'll go 2 feet by 3 feet by 1.5 feet for a volume of the wheelbarrow of 9 cubic feet. Okay. Now, if we were just asked how many times the wheelbarrow soil could be dumped into the truck until it's full, we could just divide 528 by 9, and that would tell us the number of loads of the wheelbarrow until the truck is full. But this problem's a little more challenging. They're asked for how many times the wheelbarrow would need to be dumped into the truck until it's 70% full. And we know with percent problems, these are proportional relationships, and we can use y equals kx, or we can use the butterfly method. For this problem, I'm going to demo it using the butterfly method. And I'm going to do it as follows, okay? So we have 70% over 100 equals, remember it's part over whole equals percent over 100. So the part in this case, meaning how much of it, like if we imagine you're filling this up to 70%, like how much soil is that? What is 70% of 528? We actually don't know. So I'm just going to say, call that S for soil. S for soil. Actually, I'm not going to do that because that looks like a 5, and that's going to confuse me. Call it D for dirt. All right. And we got 528. Okay, so we got the part over the whole equals 70 over 100. Okay, I'm going to solve by cross multiplying. 528 times 70. 528 times 70 equals 100 times D. And I'll multiply 528 times 70, which brings me to 36960. And then I'll solve for D by dividing both sides by 100. Bring down the equal sign, which leaves me on this side just with D. D equals 3, 6, let's see, 1, 2, so it's 369.6 cubic feet. Okay, so we're not done with this problem. We have correctly found an important step though. We have found what 70% of 528 cubic feet is. And that amount is 369.6 cubic feet. Let's go back to what the question is asking us. What is the minimum number of times Johnny needs to use the wheelbarrow until the delivery truck is 70% full? They didn't ask us how much soil will cause the truck to be 70% full. If they did, we'd be done at this point. But we're now going to use this amount to figure out how many wheelbarrows worth this is going to equal out to, okay? So we know that it needs to equal a total of, let's say, we'll just go like this. We'll say W with a little b, that's going to be number of wheelbarrow loads, okay? All right, so we got some unknown number of the wheelbarrow loads times the amount of cubic feet of soil in each load, which is 9 cubic feet, which needs to come out to equal our total of 369.6 cubic feet. And then I'm going to solve for the loads of wheelbarrow by dividing both sides by 9. And we're going to get a value of 41.06 repeating loads of the wheelbarrow. Okay, now that's interesting. I thought maybe I'd get like a clean number. Let's go back to what the problem is asking us. It says, what is the minimum number of times Johnny needs to use the wheelbarrow until it's 70% full? So precisely, it would be 41.06. But here's the issue. This word minimum here is kind of implying that like they want us to sort of cap it off at something. And we can take that to mean they want to know like an exact number, not exact rather, a whole number of wheelbarrow loads. So based on this, I'm thinking, well, is it 41 wheelbarrow loads or is it 42? Well, if I did 41 wheelbarrow loads, that would not exactly reach 70%. And so we would need to bump that up and just jump it up to 42 wheelbarrow loads, which will be more than 70%. But in these problems where they're asking you what is the minimum number of times, we're not going to stop short of 70, okay? It's based on how the problem is phrasing it, okay? So the minimum number of times until it's 70%, if it's 41 loads, that's not going to reach 70%. We would have to go up to 42 loads, okay? If they instead asked us how many wheelbarrow loads would get as close as possible to 70% without going over, then I would have to think about that carefully, and I would say, okay, that's actually 41 loads, as close as you can get. So it's all in how the problem is phrasing it and thinking about like what makes sense in the context of this problem. So your final answer here is 42 wheelbarrow loads, okay? That's going to be your final answer.